I'm CK. Tonight we've got a kit from Sonic Potions. I haven't done anything by them before. It is their Penrose Quantizer module. It'll take an incoming continuous CV signal and move it to the nearest note in a scale you select. They also say you can use it as a semi-random melody generator for fast chiptune arpeggios and much more. So I don't know how to do that with this, but we'll see. Let's put it together, see how it works, and I hope you enjoy the video. And again, as we start, I've moved the side camera to the left instead of the right, just because I think it looks better that way. I was looking at an old video and I think it looks better this way. If you disagree, please let me know in the comments which side you would like to see, or if you'd like to see a different angle. I don't know, I'm just kind of doing what I think looks good. So this kit was packed by Tubom in Germany. Let's see what's in the bag. Here's the title card, and the title card has select the active notes. Active lights light up green, the currently played note red. Lights when a gate signal is generated, down here. Input, CV between 0 and 10 volts. So it's not -5 to -5, it's 0 to +10. Then trigger input. The output voltage will only change if a trigger is received, otherwise the output is updated continuously. Gate output, a gate signal is generated whenever the output voltage changes. And 6 is quantized CV between 0 and 10 volts. And 2.5 milliamps current draw, 60 milliamp on the +12 side. That's pretty low power. 6 HP, pretty narrow, and 40 millimeters depth. Not bad. A tidy little unit. And they have a link to the build guide, so we'll check that out. Power cable. Looks dandy. Get a couple of bins out. Let's look at the front panel. I thought I had ordered black because I usually order black. Where did I put my... I usually order black, but I guess I didn't, or they didn't have it available, one way or the other. Oh, now I gotta fight packaging. Yes, you will, in one of these videos, see me slash my finger open at some point with my X-Acto knife as I get frustrated taking these things apart. Okie doke. So again, looks pretty good. Nice aluminum front panel. And ins are aluminum, outs are black. I like that. I always like that. And these are, if you look at it, that's a C scale. Like on a piano or whatever. Oh, one other thing, this kit is open source, so the schematic for the circuit board and the software is available if you want to modify it. You'll also notice on the back we've got a little stud for mounting the circuit boards. I guess we'll figure that out when we get there. Let's see what we've got. Circuit boards look good. They are through-hole plated. And we've got all the button lights, light up buttons. We've got some resistors. The resistors do have their values. They're a little hard to read, but that's okay. And there's some stand-up resistors here. As we know, I don't like stand-up resistors much, but we'll deal with it. There's a TL072 op amp on this board. That's interesting with its two decoupling caps. And then, Oh, there's a trimmer right here. That's interesting. An Atmel Mega chip as the processor, microcontroller, and then here these are pin headers to connect the boards, and the power connectors down here. MCP 602, I forget what that is, I'll look it up. And a 20 megahertz crystal goes there. Looks like a pretty straightforward build. Let's look at the actual parts. Bunch of resistors, but not too, and the trimmer, but not too many. Resistor time won't be too long today. Some caps, mostly decoupling caps, and a couple of 3 electrolytics. Here are the chips. A couple of more caps, interestingly enough. There's a little plastic bracket kind of thing there. That's interesting. Some diodes, and there's the crystal, 1 green LED, and a transistor. Maybe that's a power regulator, voltage regulator. I'll look it up. Mechanical bits, pin headers, female pin headers, jacks. These are the all plastic body jacks with some good panel nuts, some spacers, and here are the little light up push buttons. I'm going to take one out and see how they feel. First I'm going to look to see if they're, yeah, they've got, you probably can barely see that, there's a little red line there. I assume that matches a polarity or connection set. Oh wait, no, There's a green side and a red side, so they have colors. Active notes light up green, and the currently playing note is red, so that's just the connection, so you get the red-green connection correct. Let me look on the circuit board to see if there's any indicator on the circuit board of that, and I don't see one. We'll look at the build guide so we can know whether the red stripe goes to the outside or the green stripe goes to the outside. Now let's feel how they click. Oh, they're good clicky. They've got a good clickiness to them. Plastic seems a little bit delicate, so I'm going to be careful with those before we get them fully in the rack. Put these back away. So that's what we've got in the package. Looks like a pretty straightforward build. Not going to be too long a build, so I'll get the soldering iron heated up and we'll start putting this thing together. And I look to the build guide. It's a good build guide. Lots of pictures. And they do the 2 boards separately. I'm probably not going to do that. I'm going to put all the components of a certain type on both boards as we're going along. And we start with, as is typical, our resistors. And we're going to do all the lie-down resistors first, and then we'll do the stand-ups near the end of the build. So we'll go ahead and put all these on. Let's do one of them first to see how the board takes solder and how far we have to bend the legs in on the resistor to fit the holes. Here's a 10K right here. Oh yeah, we got to bend the legs right up close to the body on these. The holes are very close together. In fact, they're, let's see, yeah, you want to bend these right up against the body. I got to get my needle nose to pull that through. That's very, very tight. Now let's solder that to see how the board takes solder. very well. See if it wicked through, and it wicked through completely to the other side. So that is good. Let me clip these leads off. Now we'll do all the rest of the resistors because there's not much more to say about them, except of course for the stand-ups. We'll wait for those for later. And that means it's resistor time, so we'll go into fast motion and no commentary. That's all the lie flat resistors on both sides. Now we'll do the diodes. Now we'll do some caps. We'll do all the 104, the 100 nanofarad decouplers, and you'll find them near the chips. So around the chips is where they're scattered, as close to the pins of the chip as possible to do their job correctly. You can read up about that, about what value they provide to providing steady, relatively noise-free power to the chip. I don't like to fight these out of the tape, I just clip the leads. Oops. Not all of them at once, because if I do all of them at once, I will probably drop some and never find them again. I think he may have given us one more, unless that goes on the other board, because his instructions are board by board, and I'm doing both boards at the same time, because it's the kind of guy I am. And we'll go back into fast motion as I put these rest of these caps on. Now we've got all the small caps on both boards. One thing I do want to point out in the build guide, there are a number of parts that say marked with a red dot, marked with a black dot. The parts I have are not marked with any dots. It's not a big deal, just don't be surprised if you don't have parts with dots. Now we're going to put the two fuses on, and this is a little bit unusual to have actual fuses in a eurorack board. Now one thing he says, he recommends cutting off the legs because they've got the little bend, the kink in them. I don't do that. I use my needle nose and just straighten them out. I find that to be just as effective and gives me a little more leg room. Get it? And they go in spots F1 and F2. Now we're going to put the timing crystal on. Again, they're not polarized. And this is a little pad for it to sit on top of. I'm not quite sure why. And now we're going to put all the IC sockets on the board. And now we'll do all the standing resistors. Now he's very clear, and it's important to note that there are 200 ohm resistors that apparently people have gotten the orientation wrong, so be very careful. Those are important, but the ones he's talking about are these two, here and here, because you could accidentally go from here to here and here to here. You don't want to. You want to do it horizontally. If you look at the circle that shows where the base of the stand-up resistor goes, you'll see a little white line indicating the direction that the other lead should go. Let me back off, and we'll go ahead and do that. Now to do stand-up resistors, which if you've watched some of my other videos, you know I don't particularly care for. You take the resistor, you bend one lead all the way over the body of it, like so, and then you put the resistor body into the round circle part, and you put the other lead in the hole that is pointed to by that little notch I showed you. Now next, we've got a tantalum cap to put on. He indicates this says 106 on it. It does not. This is a different part, but it's supposed to be 10 microfarad, and if we put it on the meter, if I can get the freaking clips on, you can see that comes out at 10 microfarads, so it is the right part. I mean, it is the right value, but just a different part number from what he has in the build guide, which is not unusual. Then we've got our standard 3 electrolytics. Nothing too unusual about them. Now the voltage regulator and the transistor, and always remember, double check your parts because they look very similar. Of course, is in Q2. Now we're going to put the pin headers on. Where is the pin header bag? There's the pin header bag. So the boards are going to go together, now that you can see what we're doing with the pin headers. The boards are going to go together kind of like that. And the power connector is going to be here on the back. And now, since we've got everything together, we'll go ahead and put the ICs in their sockets. Now again, the parts he lists on the build guide are not quite like this DAC digital analog converter. He lists it as an MCP 4801. This is actually an MPC 4811. I'm sure that they're functionally equivalent. So this board is now done, except for the power connector. Speaking of which, where is, oh, he didn't give you a pre-cut power connector. We got to cut it down. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So go 1. It's going to be a little trickier than usual. 1, 2, 3, 4, 5. Do a cut here. And there it goes flying across the workbench. Fortunately, I have sides on my workbench to catch parts that go flying off all over the place. I'm going to switch this around this way. Now there's one other connector on the board here, the ISP connector. I'm not going to put it on because I am never going to program this chip, so I'm not going to bother putting that connection on, that connector on. Now, before we put this aside, I'm going to go through and look at every solder joint for two things. One, to make sure they're soldered, because you'd be surprised how you can miss them. Second, to make sure the solder connection is good. It's not shorting against anything else. So that board is done. Now, we'll go to this one, and I guess we don't have spare pin headers because we're going to use all these on this board. But not right yet. Let's see what he says to do first. Probably some things that I've already done. Yeah, all the resistors. I want to double check that I've got all the resistors on the board. Yep. And all the caps. 1, 2, 3, 4. 1, 2, 3, 4. Good. And again, the 1 nanofarad cap, he says it's been marked with a black dot. It has not been marked with a black dot, so don't expect to see dots on these. IC socket, which we've already done. Standing resistors, which we've already done. So now we'll do the 2 pin headers for this side of the board. Now put the trimmer on. Yeah, the pins are keyed, so you don't have to worry about where the screw goes. Also, it goes that way so you can actually use it when it's installed. Okay, now we're going to put all the buttons on, and we're just going to set them in place. I'm actually going to put the IC on the op amp in here first, because we're getting close to buttoning up the top side, and I don't want to have to go in, come back out, go in, come back out. So we'll just put the op amp in its socket. Oops, and I put it in backwards because I wasn't paying attention. I was saying, oh, where's the notch? Because it doesn't have a notch, it has a dot. As they do. There it is. Now it's where it's supposed to be. So to the question earlier about the red stripe and the green stripe, red leg has to be on the left side. Or if you're holding it this way, red leg's up top. Now one thing that he mentions is, because it's true, there is a small alignment pin right here, and there's a small hole in the circuit board for that alignment pin to go in. It's not big enough to really make a huge amount of tactile difference, so you want to make sure you check the colors and not that pin, because that pin's not going to tell you much. Now I'm not going to solder these right yet, not even tacking down one leg, because it's going to be really important that everything is all aligned, and I want to do it once once the jacks are on. Now we'll go ahead and put the jacks in place. That's the jacks on. Next I'm going to drop the LED in. Now I'm going to do one piece of prep on the front panel. We're going to take this female spacer and screw it on to the stud that's on the back of the board. Now we're going to mate everything together, and this will be a little fiddly to get all the buttons and jacks lined up. That was not the easiest one I've ever put together. I'm surprised that was harder even than Division 6's sequencer, which has many more LEDs and switches than this. Now we can put this spacer on here, and that'll lock the two boards together, which is going to allow us to do some soldering. The other thing I'm going to do is I'm going to solder one of these jack legs, like so, and then put a panel nut on that. So now it's locked down at the top and the bottom. So let's make sure all the buttons work smoothly and that they're firmly seated in the board, which they all appear to be. Now I'm going to go ahead and push the LED through, and it sticks out, and I'm not a big fan of LEDs sticking out, so I'm going to take a little bit of painter's tape, 7-day tape, whatever you want to call it, and I'm going to put it over the hole and push the LED up against it, because then it'll be flush with the front of the panel instead of sticking through. And that's personal preference. Those connections are all soldered, and once again I'm going to go through them all, because particularly when you got 20 or 30, it can happen that you miss one. And I still have to trim the LED leads. Nope, all those solder joints look good. Trim the LEDs off. Now we'll mate the two boards. Oops. I'm being careful not to put force on these buttons, so I'm pressing the boards down just on the front panel itself. And the jacks, I think he mentioned this. Make sure the 3 electrolytics do not touch the upper PCB. Well, they don't touch, but they touch the jack leads. So what I'm going to do, only this one, double check that. No, it doesn't actually touch. Let me get my card in. No, I can slide my playing card, my index card through, so they're not actually touching. Now I can put this screw in here. Power cable on, making sure the red stripe goes on this side. And that couple of panel nuts would be nice too, just to make it look pretty. So there we go. That's the front. It's one side, the back, other side, top, and the bottom. Now we'll put it in the rack and play with it. Okay, let's do a little calibration. First I'm going to turn it on. I'm plugging in my little route master here. And we've got two modules hooked up. We've got the quantizer here, and I've got a random oscillator there. And on the scope we can look at the frequency, and they would like us to dial that up. And on the quantizer I've got just one note selected. I'm putting 1 volt in right now, and we'll take this down to 1 kilohertz. I dropped it. Take it down a little bit more, a little bit more, a little bit more, a little bit more, a little bit more. Yep, too low. I would like to get it as close to 1K as I can, just because it makes the adjustment a little easier. Okay, that's 1 kilohertz. Frequency, now I'm going to go up until, on voltage until it changes. I'm going to go up 1 volt. I think that'll do it. Okay, 1 volt. Took it up to 1.99 kilohertz. That's pretty dang good. This is pretty well calibrated as it is. Because if it's 1 volt per octave, that's what we're getting here. I'm going to go down a volt again. And we're back to 1.1, and I go up a volt, and it's 1.9798 to 2.0. I mean, I can't do much better than that. Let me take it up to 3 volts. And 3 volts takes us, wow. That should be 4, and it's close. It's actually closer than I thought at 377. So I'm going to see what happens when I tweak this pot. It's going down, so I want to go the other way. There, it's at 4K now. Now we'll drop back down to 2 volts. And it's 1.9. If I drop down to 1 volt, it's at 1.08. That still is pretty dang good. I'm going to tweak it just a hair here. That's 1.1. Let's see what that does again. It takes us to 197, which is pretty close. Now we'll go to 3, and that puts us at 3.7, so we do want to go up a little bit more. And now we'll go down to 2 volts again. And that's 2.06. I'm comfortable with that. And at 1 volt, it is at 1.07 again. I'm comfortable with that. 2.4, 3.89, 3.92, that's good. I'm going to go up to 4 volts just to see. So that, I just went down to 3 again. So that's 3.9, 4 volts gives us 7.4. That's a little bit low. 3.75 is not good. Let me take this trimmer up again. Again, this is, you chase, don't you? I'm going to take this up to, say, 7.8. That's 7.8. And I drop it back down to 3 volts. And that's 4.12, I'm okay with that. 2.13, 1.09, I'm going back up again. And then I'm going to go up to another, that's 15. That's not terrible. Going to go down to 4 again. 7.84 at 4 volts. 4.1, 2.1, and 1.1. Doubling each time, of course. It's not going up past 20. So I'm going to live with this. We'll see what it actually sounds like when we put it in the rack, but the calibration seems okay. So now I'll put it in the rack and we'll actually put some hear what the actual output sounds. Okay, so we're plugged in and I've got the DC power supply plugged in again to start out with. So we'll start, it's at 3 volts right now, and we'll hear how that sounds. Going into my even VCO. And I've got a number of lights lit up, but I can take them all off. I can take them all off and we just get that one. And when I change the voltage, that's 1 volt, 2 volt, 3 volt. Now it becomes more interesting when I do this. Turn on a bunch of stuff. Now I'm going to drop down to 2 volts. See how it zippered? Let me turn all the notes on. So that's a pretty nice arpeggio, but you're probably not going to have a DC power supply sitting at your performance station, so let's try using the LFO. So we can speed that up. And I can change the voltage out level too. Let's try another waveform. Now they also mentioned using it with the sequencer, so I'll plug my sequencer in here. I'm not sure whether this is going to do much because the notes that I have in this sequence right now are pretty close together. We'll see. So let me do one other thing while I'm doing this, so just to make sure we're getting it right, I'm going to bring up my tuner and see whether this is actually quantized to the notes we expected. So that seems to be hitting the notes right on where I expected them to be. So it's a fun little module. Again, getting precise note values out of CV variable voltage ranges is good. So we're always hitting exactly on, it's making the transition exactly at the point we expect it to. There are some other things you can do with trigger and gate that I'm not going to be messing with right now. But that's a good overview of how the Penrose works. It's a nice little unit, as you saw, pretty straightforward to put together, even though it took a little bit of time. But I think I'll be able to play with this and do some interesting stuff with it. Hope you enjoyed the video.